All right, we're going to start talking about functions, and we are going to take down the definition, and it will go into your dictionary later. But right now, let's just take it down quickly, and then we'll start to work with it so we get a better idea. We're going to talk about functions, and functions are a special type of relations, okay? So relations, remember, if you think about our dictionary, you look at your dictionary, relations were just a set of ordered pairs. They were just points that were connected somehow. So functions are a special type of relations. And the reason that they're special is that each input, that's another way of saying x values, each x value only gives one output or y value. Okay, so each time you put an x into the left part of your table, you only get a result of one y. We'll see kind of what that looks like as we examine the problems that we have to do. We're going to skip this graphic organizer in the middle. We'll fill that out together later. And we're going to start working and figuring out whether each x has one y. And I'll do an example from each section so that you can see what it looks like. If I'm looking at number 1, the first thing I'm going to do is to make sure that I am looking at my x values separately from my y values. Remember, we have to examine, does each of these x values, each of these pink values, only give us one output or y value? So I'm going to take a look and see how these are matched up. I'm going to take a look and see that 5 is matched up with -2, 3 is matched up with -5, 2 is matched up with -5, 0 is matched up with -2, and -1 is matched up with -3. Each of these numbers only appears one time in my coordinate pairs, which means it's only got one y value that it is matched with. If it were matched with more than one y value, then I would see repetition here. We'll see that in the next one. Because there are no repeating x values, we are going to say that, yes, this is a special type of relation called a function. Okay. Let's do one more and let's look at number 2. Let's take a look at all of our x values. Whoops. Gotta get my highlighter. 2, 0, 2, 3, 2. Okay. Then my blue highlighter for my y values. Now I'm going to take a look at each of these points. I've got -2 paired with 3. I've got 0 paired with 1. I've got 2 paired with -4. 3 paired with -1. But look here, I also have 2 paired with 4. I'm going to circle these two because they're pretty important. If my input value, my pink, my 2 calculates a -4 in this row of my table, pretending these are in a table, and then 2 also calculates +4. That means that the value of 2 has 2 separate numbers as outputs, has -4 and +4. Because this repeats in my coordinate pairs, I can easily see that the input value, the x value of 2, has an output of -4 and has a y value output of +4. This one does not meet the qualification of having one output for each input. Because of that repeating x value, I can say, no, not a function. If we move up and take a look at our tables, it can be pretty easy to see here. If I kind of make a little, I'm going to highlight again. I'm just going to remind myself I've got my x values over here, my y values here, and I do a comparison. I'm going to scan down this column, and I notice that the number 3 here, I'm going to circle it again. If I input the number 3 and I do some calculations, 3 will calculate a total value of 5 for y, but 3 will also calculate a total value of 3 here. So the input value of 3 does not have one output value. The input value of 3 has two separate outputs. It has 5 and it has 3. The repetition of my 3's here and here in a table tell me that this is not a function. I do not have one output for each input. You can put no, you can put not a function, indicate somehow that that is not a function. It's a relation because it's a set of points they say are connected, but it is not a function. Now your mapping diagrams were a pretty good view of this. What you can see in your mapping diagram, remembering that this over here is your domain, right, listed on the left, and these numbers are your range. If you need a reminder, remember your domain are your x values, and your range are your y values. So if I look at this, I can see that -3 only calculates a 0, -1 only calculates a 4, 2 only calculates a 7, and 4 only calculates a 4. Because each of these numbers only has one arrow, one match for the input, this is considered a function. Some people are concerned because this number here, 4, shares a couple input values. It doesn't really matter. For the purpose of a function, we need each of these values, each of our x values, to only calculate one number. And even if it's all the same number, it doesn't matter. But each of these can only calculate one thing. There can only be one arrow coming from each x value. Let's move to the next page. Take a look at some of these. Now we've got to take a look at our graphs, and we've got to be able to see, are there any x values that share a y value? And we're going to do a little bit of scanning. We're going to look, and this is an x value, if you start at your origin, of over -3. And if I look up and down this over -3 line, I can see that no other points are shared at -3. So that means the x value of -3 only has an output right here of down -2. Right here, this has an x value of -1 because I go over -1. And if I go up and down, there's only one y value with a dot here. On the other hand, if I go over to +1, what I notice is right here, if I input over +1, I get this dot. And if I input over +1, I also get this dot. Because these two x values are shared here, there's two repeated x values, this is not a function.